Hello class, this is a video tutorial on calculating the length of missing sides, sorry, little typo there, missing sides using trigonometry. This is the second part to a two-part series, and you'll see why in a moment, if you go back to my previous video on this, why we do two parts, as depending on where the position is of the information, the method that we do changes ever so slightly. Okay, so let's begin straight away here. So, as with most trigonometry, almost all trigonometry, we need to determine which of the ratios we must use. So from our angle, we are given this side here, which is the opposite, and this unknown angle here, which is the hypotenuse. So that is sine. Sine is SOH, SOH. So if we place these pieces of information into the proper ratio, so sine 15 degrees 10 minutes is equal to 2.62 over x. Notice how in the previous video it is x which is on top. At this point it works out fairly similarly, but there's a bit of an extra step here. In the previous video we multiplied by whatever value was here, but we do the same thing, so we're going to be multiplying by x, and then we're going to be multiplying by x on this side as well. This will result in us having this kind of an odd expression. We get x sine 15 degrees 10 minutes is equal to 2.62. But we're not done here. This is the extra step that we have to do. In order for x to be by its own, we have to remove this value here. And since this is x times sine 15 degrees 10 minutes, we can actually divide. Let me erase these things here a little bit neater. We can actually divide both sides by this value here. So I'm going to divide, hang on, let me write this neatly. Going to divide both sides by sine 15 degrees 10 minutes. Divide both sides by sine 15 degrees 10 minutes. What this will effectively do is these two will now disappear. They will cancel each other out, which will leave us with x is equal to 2.62 divided by sine 15 degrees 10 minutes. I'm going to continue this calculation up here. Now this is the value which we need to input into our calculator. So it'll be x is equal to so it'll be fraction 2.62 divided by sine 15 degrees 10 minutes. Make sure you close that fraction. Oh, sorry, close that bracket because it's open and it has to end. When you press equals, we get a value of 10.01. 10.014. And like we did in the previous video, we're going to round this to 2 decimal places, which will give us 10.01 centimeters. Let's just say that is at 2 decimal places. Now, I know that's a little bit trickier than the previous one. If that made sense, that's good. But if you just take a look, if we eliminate that middle step, you can sort of see how the sine 15 degrees 10 minutes and the x sort of swapped from this step to this step. Notice how the x was the denominator but then after 2 steps, they sort of swapped with this position here. That's a good little trick that you can use to remember, and I'll demonstrate it with this one. If you understood that, pause the video and give these answers a go. Give these questions a go. Here we go. Let's solve this question now. Let's solve B. I'll demonstrate to you the little trick I mean about the swap. The swap. From our angle, we are given the adjacent and the hypotenuse. So that is now going to be, oh, not sine, cos 20 degrees 30 minutes is equal to adjacent over hypotenuse, which is 14.52 over x. Now we can do this long process here, or we can just say the x and the trig ratio will swap, so it'll give us x is equal to 14.52 over cos 20 degrees 30 minutes. Inputting this into our calculator, we will get fraction 14.52 divided by cos 20 degrees 30 minutes, closing the bracket, equals, that will give us 15.501, and rounding that up to 2 decimal places, 15.5 centimeters at 2 decimal place value. Let's move right along. Here we are once again. From this position, what information we have? So from our reference angle, we have the opposites and we have the adjacent, OA. This will now give us tan of our angle, 37 degrees, 2 minutes is equal to 15.2 over x. Since it's over x, we're going to swap those two values, which is 15.2 over tan 37 degrees 2 minutes. Inputting that value into our calculator, 15.2 over tan 37 degrees 2 minutes. That will give us 20.146. Rounding that up gives us 20.15 centimeters. That is at 2 decimal places. And our last question here. From our angle, we are given the opposite and the hypotenuse. That means we have to use sine. Sine 62 degrees 3 minutes is equal to 2.65 opposites over hypotenuse, which is x. Swapping those two values gives us x is equal to 2.65 over sine 62 degrees 3 minutes. Inputting that value gives us fraction 2.65 over sine 62 degrees 3 minutes. Closing our bracket. That gives us 2.99999, which is equal to 2.999. And obviously that's very close to the value of 3 centimeters. Yes, it is 3 centimeters because if we round this up, it forces to this to go up, which forces that to go up. So that is still at 2 decimal places. At this point, I invite you to look back at the previous video and compare these two different examples. And yeah, hope I gave you an insight into this topic. Best of luck.